Well, welcome. We have a privilege tonight to hear a guest speaker. Yes, indeed. Spike Psarris is going to come and speak with us tonight. He was in the Military Space Academy for, is that right? Military Space Program, for about a decade. He went in as, I'm sure he'll share more about this, but he went in as an atheist and as an evolutionist. He left as a creationist and a believer in Jesus Christ. And he's been, absolutely, and he's been sharing, obviously, about the Lord and about creation for about the last 20 years. He's a wealth of information. We're really privileged to have him. So with no further introduction, please welcome Spike Psarris.
Well, thank you. It is my privilege to be before you here this evening and talking, as I love to do, on the Lord's creation and what we can learn about Him from seeing the cosmos around us. And I have actually spoken here before. I think it was about 3 years or so ago now. But I know a lot of you don't know me from a hole in the ground, so let me help you out here. This is me, and this is a hole in the ground. So I want to get that cleared up right away. Specifically why I'm here, though, I'm a sinner saved by grace. That wasn't always the case. I used to be just a sinner. I was an atheist for well into my adult life, still more than half my life at this point. And as was said in the introduction, I was in the military space program when that transformation occurred. That was not an instantaneous thing. It took quite a while. And it also happened in the order that was spoken. I became a creationist and then a Christian. And I like to say it in that order because that's how it happened. And also because there are many in the creation-evolution debate that like to say that Christians believe in creation because we're Christians. That because we have this faith in the Bible that we therefore say it's true, and so we basically put blinders on and we don't see all this obvious evidence for how the world came into existence without a creator, the millions of years and evolution and all the rest of it. Well, I'm one of many for whom the opposite is true. I became convinced by the evidence first that creation was true, and then became a Christian afterward. Now, believing in creation is not sufficient to make one a Christian, right? I mean, that's the work of the Holy Spirit. There are Muslims who believe in creation, for example. But again, I like to emphasize that point, that there is lots of evidence on our side. I would argue all the evidence is on our side if you look at it properly. And so we don't have to be afraid of science, because truly the heavens do declare the glory of God. Now, of course, that's not the only interpretation that's offered to us in our society today. And really, when we look at the universe around us, there's two basic interpretations. Either everything was created or it wasn't. Now, of course, there's different varieties of it wasn't, but those are your two basic choices. And of course, the biblical interpretation that says everything was created says that in the beginning, God created the heavens and the earth. I hope that's a familiar verse to most of us. But of course, we're told that that's an illegitimate interpretation. We're not allowed to use that as a legitimate interpretation in our society today, because that's a supernatural explanation. Now, the word super just means that which is above or beyond. So that which is supernatural is that which is above or beyond the natural world. And we are told that only naturalism is an allowable way of viewing things in science. Naturalism is the idea that only natural processes are allowed as explanations. And the most popular naturalistic explanation for how the universe got here is shown on this timeline that in the beginning, about almost 14 billion years ago, there was a Big Bang. That Big Bang made a bunch of gas, hydrogen and helium, maybe a little lithium, but that was about it. From that gas, the first stars formed. Those stars then gathered themselves into galaxies, and this all took billions of years, of course. One of those galaxies is our own Milky Way, and then inside the Milky Way is our solar system, which we'll talk about in just a moment. And then within the solar system is the planet Earth, where we are today looking at it all. Now, both sides in the creation-evolution debate would agree that we are indeed on the Earth looking at it all, but the rest of this timeline is up for dispute. So let's talk briefly about each of these steps in this timeline, and we'll start with the most recent one, the formation of the solar system. Now, what you're being told is this, that in the beginning, there was gas. And then that gas collapsed under the force of gravity and began to swirl around. From the gas, grains of dust condensed. The dust then stuck together to become little rocks. The little rocks stuck together to become bigger rocks. The bigger rocks stuck together to become what are called planetesimals, which means asteroids. The word means little planets, but asteroids basically. And then the asteroids stuck together in various ways to become the planets we see. Now, you'll be told in the textbooks and science programs and all the rest of it that this is how it all got here. Minor detail, though, is that the model doesn't actually work. You can get dust from gas, and you can get dust to stick together. Just look under your furniture for proof of that, right? But what you don't get is rocks beyond about this big. When the rocks get to be about this big, they have enough mass to start breaking each other apart as they collide. I mean, these things are going thousands of miles an hour. So imagine smashing boulders together thousands of miles an hour. Do you get bigger boulders as a result of that, or do you get rubble? You get rubble. But at this size, there's not enough mass there to have enough gravity to pull the rubble together to make bigger things. So enough mass to be destructive, not enough mass to overcome that with constructive gravity. And so this is where formation stops, this size right here, which is why you see quotes like this one. This is one of my astrophysics textbooks. Once these planetesimals have been formed, the planetesimals being asteroids, further growth of planets may occur through their gravitational accretion into large bodies, but just how that takes place is not understood. The formation of planetesimals, the kilometer-sized planetary precursors, is still a puzzling process. And by the way, I'm quoting a lot of people in my presentation this evening. Unless I say otherwise, they're all secular. They do not accept creation. So you're hearing this in their own words. How the first stage of this process, primary accretion, works is a fundamental unsolved problem of planetary science. Now, do they know that they have this problem in their models? Well, yes, of course they do. I'm quoting them. How do they get around this? Well, they've been struggling with this for a long time now, because this is basic physics here. I mean, rocks traveling thousands of miles an hour make little rocks, not big ones. So the current favored explanation is that, as this quote says, objects must have grown very rapidly from sub-meter-sized pebbles into 100-kilometer-sized bodies, possibly in a single leap. In other words, rocks this big turned into rocks the size of Rhode Island without passing through intermediate stages or sizes. Is this a scientific model? Or is this a bunch of hand-waving to paper over some big problems in the model? So we could actually stop right there as far as the solar system is concerned, because the secular modelers don't have any building blocks to make anything from. But let's set that aside for a few minutes and move on and see what else we can glean. So this is a depiction of the solar system. This is the sun, and this is to scale with all the objects. So in real life, they're much farther away from each other than this, but as far as size goes, this is roughly how they are compared to each other. So the sun's Latin name is Sol, so therefore this is the solar system. And there are planets here orbiting the sun. From the closest to the farthest, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto got demoted, so he's not there anymore. Now, we can actually go through each of these planets and discuss how each one discredits the secular model in a different way. That's beyond the scope of our discussion tonight, but let's just hit a few highlights. The planets closest to the sun are called terrestrial planets. The Latin name for Earth is Terra, and Earth is rocky. Since these other three planets, Mercury, Venus, and Mars, are also rocky, they are called terrestrial planets. And again, there's a lot of useful things there for us, but tonight I'm going to move on and talk about, briefly, some of the gas giants, being Jupiter, Saturn, and then Uranus and Neptune are considered more ice giants than gas giants. Here's the Earth to scale. I apologize if I'm in front of it from your perspective, but you can see how big these objects are compared to the Earth. Now, if you're a secular model and you want to account for something like Jupiter in your model, well, Jupiter's a really big planet. It's famous for its giant red spot, this giant storm system here, which is actually bigger than the entire Earth is. It's a very violent storm, as you can imagine. Now, if you want to make a planet this big, you need a lot of stuff to make it from in your model, don't you? And as we already said, the secular model doesn't have the building blocks to make things from, because they can't make planetesimals. As this author said, how this process, this planet building process, continues from meter-sized boulders to kilometer-scale planetesimals is a major unsolved problem. Boulders are expected to stick together poorly, as I told you about earlier. And now here's a second problem I didn't tell you about. And to spiral into the protostar, i.e. the sun, that's forming, in a few hundred orbits owing to a headwind from the slower rotating gas. So the idea here is this: if you swim through molasses instead of water, does that slow you down or speed you up? That slows you down. You're plowing through this stuff, right? Well, if you're a boulder plowing through a cloud of gas and dust, that also slows you down. And in orbits, the way they work is when you slow down, you move inward toward the thing you're orbiting. So as this author is pointing out here, the models say that even if you could somehow get the rocks to stick together, that still doesn't help you much because those rocks are going to spiral all the way into the sun before planets have a chance to form. So we see, for multiple reasons, the planets don't have building blocks to make them. And oh, by the way, some of these planets have important chemical differences between their measured composition, that which we see, and what the models say they should have. So if you ask a question, where did Jupiter come from? Well, as this author said, Jupiter is the largest of all the planets, but results that were published in Nature, a scientific journal, now reveal the embarrassing fact that we know next to nothing about how or where it formed. Now, for those of you who like science, who heard about this problem in, for example, the Cosmos TV program, or textbooks or other things? I mean, is this the perspective that's presented to the public when they talk about such things? Or do they say, oh yeah, we have it all figured out, there was this gas, and then there's rocks, and then there's planets, and no problem. Well, no, there's lots of problems. As this author said, I don't think the existence of Jupiter would be predicted if it weren't observed. Jupiter also has what's called the migration problem. I told you a moment ago that boulders going through the cloud of gas and dust will spiral into the sun. Well, it turns out a planet isn't special. Even if Jupiter could form from those planetesimals, it too would spiral in and migrate, as the phrase is. As this press release from Astronomy and Astrophysics said, theories predict that the giant protoplanets, proto meaning new, forming planets, will merge into the central star. That's a nice way of saying crash into the sun, before planets have time to form. This makes it very difficult to understand how they can form at all. Understanding the formation of giant planets is currently one of the major challenges for astronomers. Well, it's more than just a major challenge. I mean, the model says that the planets just really shouldn't be there. But of course, there it is. Moving outwards in the solar system, after Jupiter, we have Saturn, which is also a wonderful gas giant. Famous, of course, for its beautiful rings. We could talk more about those separately, but for now, we'll just talk about the fact that Saturn also suffers from the migration problem. It too should have spiraled all the way into the sun if this model were true. So just like Jupiter, Saturn shouldn't be there either. But of course, there it is. And I'd like to spend a few minutes talking about a couple of Saturn's moons, which are very interesting. This is Enceladus. It's a pretty little moon. It's actually the brightest object in the solar system because it reflects more sunlight off of its surface than other things. And one of our earlier pictures of Enceladus was this here. These are Saturn's rings, and the spacecraft was almost edge on to the rings, which is why they look that way. And then here's Enceladus, and maybe the lighting here, hopefully you can see there's a little smudge below Enceladus. So we were wondering, what exactly is that? Let's go take some closer pictures. Well, it turns out Enceladus has geysers of water and ice coming out of its south pole. And these are very substantial, as this false color picture shows, the amount of material being sprayed. In fact, some of Enceladus's neighbors are brighter than they otherwise would be because this moon is spray painting them with ice and snow. Now, why is that significant? Because this is not a very big object. If it were billions of years old, it would have cooled off from its formation billions of years ago. So it shouldn't have any geological energy left to do this. But it is doing that anyway. Now, if it's only thousands of years old, there's no problem because it could still be cooling off from its formation. It still has energy left within it. So thousands of years is not a problem. Billions of years is a problem. Now, in fairness, I should mention that they explain this away by telling us that Enceladus is in a gravitational tug-of-war between Saturn and some of the other moons, and so that squeezes and flexes it and inputs energy that way. That's true, but it's only a few % of the amount of energy they need to explain this. So even though that's the explanation offered, it's very inadequate. Enceladus looks very young, not billions of years old. And then we have Titan. Titan is the largest moon of Saturn. It's actually larger than the planet Mercury. And if you see this photo behind me, it looks kind of fuzzy. That's not because the moon, it's not because I'm showing you a poor quality photo, it's because the moon actually looks that way. Titan has an atmosphere. Now, the atmosphere is opaque, which means we can't see through it here from Earth. But what we can do is see how sunlight bounces off of it and comes back, back to Earth. And we can, from that, measure the chemical composition of Titan's atmosphere. And that's interesting because Titan turns out to have a lot of methane in its atmosphere. And that's interesting because methane gets broken down by sunlight. And it's not too hard of a calculation to show that all the methane in Titan's atmosphere would be totally broken down and gone after just 10 million years. Now, 10 million years is a long time, but Titan is supposed to be 4.5 billion years, which is 4,500 million. So the methane would only last 10 million. Titan is supposed to be 4,500 million years old, so the methane, of course, should have been long gone. But of course, secular scientists want to believe that it's actually these 4.5 billion, so what do? Well, they say, okay, no problem. That obviously means there's a reservoir of some sort of methane under the atmosphere where we can't see it that's replenishing the methane that's getting broken down by the sun. And then also that would imply there must be billions of years worth of ethane also on the surface here, because ethane is one of the things that methane turns into when it gets broken down. So secular astronomers, based on their belief in billions of years, predicted there would be a global ocean about 1.5 kilometers deep of methane and ethane on Titan's surface beneath the atmosphere. And it would be an ocean because those chemicals would be liquid at Titan's temperatures. But when we sent a spacecraft there and actually penetrated the atmosphere for the first time, we didn't find any global ocean. We found a surface that looks like this. This is a photograph that's sent back from the lander. The surface is very sandy. It's not the same chemical composition as beach sand on Earth, but it's a sandy texture. Point is, no ocean. The ocean's missing. Now again, thousands of years old is not a problem. The Titan fits that idea quite well. Billions of years old, this is a real head scratcher. Moving outwards in the solar system, we have the planet Uranus, and then next to it, I shouldn't say next to, it's quite a bit further out, is the planet Neptune. And there's several interesting things about these two planets, but the one I like the best is the fact that these two planets don't actually exist, according to the secular model. As this article in Astronomy Magazine pointed out, psst, astronomers who model the formation of the solar system have kept a dirty little secret. Uranus and Neptune don't exist. Or at least computer simulations have never explained how planets as big as these two gas giants could form so far from the sun. And it goes on to explain, basically the problem is when you're that far out in the solar system, you're orbiting very slowly, because that's how orbits work. Uranus and Neptune have not had enough time to have gone through that region of space enough times to have accumulated enough material to be so big as they are. And I know that was a long run sentence, I apologize. But from the secular point of view, you would need 10 billion years to build planets out there. Now, of course, the solar system is supposed to be less than half of that old, even from the secular perspective. Nor, by the way, do they have any building blocks out there to make them from anyway. So you would think, therefore, this is a problem in that the model says these two planets don't exist, but there they are. As this author says, it's clear that our level of sophistication of studying planet formation is relatively primitive. So far, it's been very difficult for anybody to come up with a scenario that actually produces Uranus and Neptune. Again, is this the perspective that's given to the public in the museums and the media and all the rest of it? No, instead, they're fed things like this. Here's possible explanations for some of these puzzles I presented to you. Wandering Jupiter accounts for our unusual solar system. It goes on to explain how Jupiter used to sweep through the early solar system, destroying a first generation of inner planets before retreating into its inner orbit. Where's the evidence for that? Where's the evidence for the planets that Jupiter supposedly destroyed? Well, the fact that they're not there anymore. Now, is this a scientific model or is it just storytelling? Was there a giant planet ejected from the solar system? These modelers are trying to invent other planets that we don't see to interact with the ones that we do see to explain some of these puzzles. But again, there's no evidence for this other planet. That's just storytelling. Our solar system may have harbored super Earths. Earth belongs to a second generation of planets. So now these modelers are saying a number of super duper Earths might have once existed in the inner solar system. Where are they now? Well, they found their demise. So now it's not just that there was one or two extra planets, there was a whole generation of planets there in the beginning. They're all gone now. Again, where's the evidence, the fact that they're not there? That's not science, storytelling. And I like this one. This one is meant to explain how Uranus can exist. Did Jupiter and Saturn play pinball with Uranus? And they have a helpful scientific simulation here to show you what they're talking about. pinball may actually not be the best word. The better word might be tennis or ping pong. But the idea is Uranus formed much further in the solar system, and Jupiter and Saturn kind of batted it back and forth. So Jupiter hit it out to Saturn, and Saturn threw it back to Jupiter, and Jupiter threw it out to Saturn. But then at one point, Saturn missed the catch, and then it went on by and took up its orbit where it is today. So that explains how Uranus can exist. The models say it can't have formed where it is, so it must have formed elsewhere, and then this whole ping pong thing happened. Well, first of all, the evidence doesn't fit that. Uranus's orbit does not look like it came from such a thing. That's just storytelling. And then the most recent addition to my talk here is to talk about Pluto. Those of you who are following the news know there's really cool stuff coming from Pluto, even since last summer, that we're still getting more data on this. Interesting, because Pluto has large areas of smooth terrain where there aren't any craters. Now, there are craters in some other places on the surface, which tells us Pluto's been hit by things that made the craters. But then there's large smooth areas, which indicates Pluto has been resurfaced. And the resurfacing had to happen very recently because there hasn't been enough time to get more craters on this smooth terrain. Well, the problem is resurfacing a planet, you're talking volcanism, stuff coming in from inside and recoating the outside. That requires geological energy. And as I've already said earlier with some of these other things, Pluto is tiny, should have cooled off billions of years ago, if it were actually billions of years old. Shouldn't have the geological energy to do any of this. So again, thousands of years old, not a problem. Pluto could still have energy left over from its creation. Billions of years old, Pluto doesn't fit. So what's the bottom line of all this? That thus far we have seen that we know very little about the development of the solar system. Again, from one of my astrophysics textbooks. To sum up, I think that all suggested accounts of the origin of the solar system are subject to serious objections. The conclusion in the present state of the subject would be that the system cannot exist. So we see this part of the secular timeline doesn't work very well. Let's step back a little bit and talk about some earlier stages and see if they do any better. How about star formation? The idea that the Big Bang made this gas and then the gas turned into stars. Well, stars are indeed made of gas. Stars are basically big hot balls of gas. And they vary in their color, their size, their temperature, their mass, and some other things, but they are all basically just balls of gas. Now, if you're going to be a secular modeler, you need to explain where stars came from, because stars are really the basic building block of the universe. Almost all the mass of the universe that we see is found in stars. Planets, comparatively are insignificant, and galaxies are just collections of stars. So again, stars are a pretty important thing to explain if you're trying to account for origins. Now, what we're told is that stars form when a gas cloud collapses under gravity. Now, we do indeed see lots of gas clouds in space, and gravity does indeed have an effect within these clouds. But gravity is not a very strong force. Now, what we're told is these clouds are big enough that there's enough stuff. Each molecule isn't pulling on its neighbors very strongly because there's not much mass here. But if you have enough of them, they will pull on each other and compress the gas. And if you remember your physics or chemistry, when you compress a gas, it gets hotter. So keep compressing, squeezing under gravity. Eventually, it'll get so hot inside that gas that nuclear fusion will ignite, and then that's what a star is, a hot ball of gas with fusion going on. Now, that's the story that's usually presented, but there's more to the story than this. Gravity is indeed at work inside of these clouds, but it's not the only thing at work. You also have gas pressure. Gravity gathers or compresses the gas together, but gas pressure drives it apart. And sometimes when I speak on this, I have as a visual aid a can of compressed air. Now imagine, if you have a can of compressed air in your hand, you have gas that's at a higher pressure than the environment. The only reason it stays pressurized is because it's in the can. As soon as you press the trigger and open a passageway from inside the can to the lower pressure environment, what does the gas do? It escapes, it goes out. Because higher pressure gas always distributes itself into a lower pressure environment. The only way you can have a high pressure system of gas is by containing it in a can, right? Obviously there's no containers in space though. So what actually happens with these things, so here's your gas cloud and this is space next to it. And by definition, a gas is made up of molecules that are not rigidly bound to each other. Because if you have molecules rigidly bound to each other, that's a solid. And if they're bound but sliding around, that's a liquid, and then when they break free completely, that's a gas, right? So we have all these molecules of gas bouncing around inside the cloud. Now, they move a little bit and they immediately run into a neighbor, they collide, and so then they bounce off in a different direction. So in here, all the gas is bouncing off of their neighbors, and no problem, that just happens. Think about, though, the very outmost layer of gas molecules here. Now, since they're all going in random directions, half of them will be going in some direction that's inward, whether straight in or over here or whatever. Those half are going to go inwards until they run into a neighbor and then bounce off and keep doing that. But half of them are going to have some variety of outward direction. Those don't have neighbors. Those go off into space, they don't hit anything, and they're gone. So the gas cloud is constantly losing the outermost layer of gas molecules. And of course, when one layer vanishes, that exposes the next one, which vanishes, which exposes the next one, and so on. Like peeling an onion until it's all gone, right? So left to its own devices, a gas cloud in space does not form stars. It dissipates. Gravity is at work here, but gravity is weak compared to gas pressure, which is much stronger, drives the molecules apart, the gas cloud goes away. Now, in case you're wondering if that's true, how can stars exist? Because I told you earlier stars are just balls of gas. That's because a star is already dense enough to sustain itself. Gravity is stronger over smaller distances, so once you have a star, once the volume is small enough, gravity is strong enough to keep the star together. It's when it's still a dispersed gas cloud, though, gravity is too weak to pull it together and overcome gas pressure. Are secular astronomers aware of this whole formation problem? Well, yes, they are. And they have several proposed solutions. They have compression, cooling, and collisions are the most popular, so let's talk about these for just a moment. Compression occurs when a supernova explosion, like this guy here, goes off next to a gas cloud. A supernova is a very violent explosion in space. The Crab Nebula, for example, is the leftover remnant of a supernova that happened in the year 1054. Chinese astronomers watched this happen, and it was visible in the daytime for a number of days. So big explosions in space, and the idea is the explosion happens next to a gas cloud. The shock front from the explosion compresses the gas cloud and does so enough that the compression kind of kickstarts gravity. I mean, gravity is already there anyway, but it compresses the cloud to its volume is small enough that gravity can then take over and stars begin to form. Secular astronomers also invoke cooling. So we had compression, now there's cooling. And the idea here is that a supernova blows particles into the cloud. So, for example, if you have a pot of water on the stove that's just barely beginning to boil and you pour a bunch of rice into it, what happens to the water? It stops boiling, right? Because the rice absorbs that heat. Well, same thing here. If you blow a bunch of particles into a gas cloud, that absorbs heat from it. And the way gases work, if you cool them down, they shrink. Their volume goes down, which makes gravity stronger because it's a smaller volume, and then again, maybe gravity can take over and make stars. So we had compression from supernovae rather. We have cooling by particles getting blown in. Then we have collisions. For example, when these two galaxies appear to be in the process of colliding, along the collision front, we see new stars, blue stars, which by anybody's reckoning don't last very long, so they're young. And this makes sense. If you have two galaxies, which are made up of stars, dust, and other things, crunch those together, and that's a form of compression, right? So you can overcome gas pressure by doing that, and then new stars can form as part of the collision. So we had compression, cooling, and collisions. Now there's a problem common to all three of those explanations, and maybe some of you picked up on it. What is a supernova? I told you it's a big explosion in space, but I didn't tell you what's exploding. A star is exploding. What about grains and particles? Where do they come from? Well, the Big Bang can't actually make any of those. Those have to be formed by nuclear fusion inside of stars. And then for galaxies to collide, they must first exist, and galaxies are composed of stars. So these three explanations are meant to explain how star formation could occur, but they all require stars to exist before more stars can form. So what does that remind you of? Right? It's the ultimate chicken and egg problem. You need stars to make more stars. Now, once you have stars, then they can interact and form new ones. So I'm not arguing that stars cannot form today. What I am arguing is that the secular modeler, who doesn't have a creator to make the first generation, can't explain how the process continued from there. And indeed, they do recognize this. The process by which an interstellar cloud is concentrated until it's held together gravitationally to become a protostar is not known. Literally hundreds of ideas on how stars are formed have been advanced in past decades, but we are still far from any real solution. The origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. And by the way, there's other problems with star formation that I don't have time to discuss, like turbulence and magnetism and some other things. The formation of stars is one of the most fundamental problems in astrophysics. No current model can reproduce all the observations. Well, that's not true. The biblical model works just fine. Great is our Lord and of great power. His understanding is infinite. So what you aren't being told about star formation is that it requires gravity to pull gas clouds together, but that's a very weak effect when compared with gas pressure, which is forcing them to disperse instead. All the explanations require old stars to make new ones, but therefore no one can explain where the first ones came from. And if you don't have stars in your model, then you don't get galaxies either, because galaxies are just big collections of stars, which is why a completely satisfactory theory of galaxy formation remains to be formulated. The formation of galaxies in larger scale structure remains TMI-UPI-MA, the most important unsolved problem in modern astrophysics. The universe we see when we look out to its furthest horizons contains 100 billion galaxies. Each of these galaxies contains another 100 billion stars. That's 10 to the 22 stars all told. A 1 with 22 zeros after it. That's how many stars there are. The silent embarrassment of modern astrophysics is that we do not know how even a single one of these stars managed to form. So going back to our secular timeline, the star formation part doesn't work so well either, which means you also don't get galaxies, which means we don't get a Milky Way galaxy. What if we go all the way back to the beginning, the formation of the entire universe itself? Let's talk about that for a moment. What we're told is that in the beginning there was this Big Bang. That Big Bang made a bunch of gas, and then the gas formed into stars and so on. We've talked about the latter half of that. Let's talk about the first part. This is a graphic from NASA that tries to compress the history of the universe into a single graphic, which is, of course would be challenging. Basically, this is the beginning, this is now, and so time goes from left to right. The Big Bang is, well, the universe was initially just a single point, a quantum fluctuation in a vacuum, we'll talk more about that then blew outwards, inflated briefly, and so you can see it went from a point to a very large thing very quickly. Now, since then, it's expanded a bit, which is why it's bigger over here than over here. But you see a great deal of that expansion happen early. And there's a lot of other steps in here that we're not going to concern ourselves with tonight. For now, I just want to talk about what is the evidence that the Big Bang occurred, because you'll be told that we have a lot of evidence for it and that this is good, proven science. Well, the initial evidence for the Big Bang was redshifts. And a redshift is a shift in the color of starlight toward the red end of the spectrum. Now, you can get redshifts different ways, and I don't want to go into this in too much detail, but the way that it's commonly interpreted is that the objects emitting the light is moving away from us. And it turns out that a few local objects are not doing this, but everything far away is. That means everything we see in all directions in space that's far away from us is moving away from us. And the farther objects are moving away from us faster than the closer ones. So that would mean that the universe is expanding. So if we're currently here and we're headed toward this way, all the galaxies are moving apart from each other. Well, now mentally run that movie backwards in your brain. That means in the past, everything used to be closer together. Go backwards even further, you get to a time when everything was at the same point in space, and that's what the Big Bang supposedly was. So Big Bang believers would tell us the redshifts are conclusive proof that the Big Bang happened. Everything is moving away from everything else now. That means in the past, everything used to be together, and that was the Big Bang. They would also say that the abundance of light elements in the cosmos, the ratios of hydrogen, helium, and especially lithium, are consistent with the Big Bang model. And then finally, they would say the conclusive proof of the Big Bang model, the one that really made it popular as a secular model, by the way, was the discovery of the cosmic microwave background. All directions in space that we look, we're seeing low temperature radiation coming to Earth from out there. And I mean very low temperature. This is a prediction of the Big Bang model. Basically, the model said there should be leftover radiation from the Big Bang visible to us out in space. And then when this was found, they said, look, Big Bang made a prediction. It's now been confirmed. Big Bang is proven. Well, all three of those pieces of evidence that I just shared with you are consistent with the Big Bang model to various degrees, but they aren't proof of the Big Bang model because they can also be explained by other cosmologies. This is outside of our scope tonight, but I just want to make the point is, yes, there is evidence that's consistent with the Big Bang, but it doesn't prove the Big Bang because it's consistent with other stuff as well, other ideas as well. But in addition to that evidence, there's other evidence that's actually against the Big Bang. For example, the more we've learned about some of these things I just told you about, the less consistent they are with the Big Bang model. And I apologize to the people trying to keep up with me signing tonight. Thank you for doing that. I know I speak quickly. For example, as we learn more about the cosmic microwave background, we're perceiving patterns of temperature differences in here that shouldn't be there according to the Big Bang model. As the headline here, Planck, that's a Planck spacecraft, which gave us our most precise measurements of the background radiation recently, shows an almost perfect cosmos plus an axis of evil. That's this temperature pattern that the Big Bang model can't accommodate. And you can tell how they feel about it because of the name they've given it. As this author said, the apparent alignment in the cosmic microwave background in one particular direction through space is called evil because it undermines our ideas about the standard cosmological model, i.e. the Big Bang. So that little section is discussing what evidence there is. Now let's continue further and discuss some other things that aren't usually brought to the conversation. Big Bang says that in the beginning there was nothing, and then it exploded. Well, what exploded? Well, nothing exploded. How can nothing explode? Well, nothing apparently can explode and did explode. That means it does explode. And nothing did explode to make everything, which is why there's everything rather than nothing. There, see how easy that is? But of course you can't go from nothing to everything. Because if you think about it, nothing can create nothing, right? Because nothing can do nothing. From nothing, nothing comes. As R.C. Sproul has pointed out, if there were ever once truly nothing, there could never be anything. Which is profound if you think about it. And as Dr. Phil Fernandez said, you can't tell me that nothing made everything. I know too much about nothing. Now, sometimes people say, well, yeah, it doesn't sound like a very probable thing, but if you wait long enough, even something which is extremely improbable will eventually occur. That doesn't get you off the hook either, though, because the Big Bang model says time did not exist before the Big Bang. Because the Big Bang made four things: matter, energy, space, and time. So if the Big Bang made time, there was no time before the Big Bang. So you can't wait long enough for an extremely improbable event to happen because there's no time within which to wait. Nor is there a place to wait anyway. So how then do secular astronomers deal with this? Well, I mean, other issues arise here. If there was no creator and there was nothing before the Big Bang, that means the universe had to create itself, right? Because there's no other option. But something can't create itself, can it? Because in order to create something, that which is doing the creating must first exist. So for something to create itself means it has to exist before it existed, which is obvious nonsense. However, secular cosmologists will say they have an explanation for this. As Stephen Hawking has said, who's an atheist, by the way, if you didn't know, he says, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, and why we exist. He then went on to explain that the laws of gravity and quantum theory allow universes to appear spontaneously from nothing. Notice universes, plural. We'll talk more about that here in a minute. But for now, my point is he's appealing to the laws of physics, gravity and quantum theory. He says they can have the universe create itself. Well, what is a law of physics? Is a law of physics a thing that can create something? What does a law of physics feel like when you hold one in your hand? I mean, this is a silly question, right? It's not a thing. So if laws of physics aren't things, what are they? A law of physics is just a mathematical formulation of a pattern of behavior that we've observed in the universe, right? I mean, if I open my fingers, then this thing falls to the ground. I do that enough times at different types of experiments. I can figure out, well, there's apparently this thing that's always going to happen, and then we can quantify that as a formulation of gravity or whatever. So if the universe didn't exist until the Big Bang, then There was no patterns of behavior of the universe before the Big Bang, and so there were no laws of physics, right? And also, I told you earlier that the Big Bang was supposedly a quantum fluctuation in a vacuum. Is a vacuum actually nothing? No, is the answer. As this secular cosmologist said, a more fundamental problem is that this scenario does not really explain the origin of the universe. A quantum fluctuation of the vacuum assumes that there was a vacuum of some pre-existing space. And we now know that vacuum is very different from nothing. Vacuum, or empty space, has energy and tension. It can bend and warp, so it is unquestionably something. And as Alan Guth, who is a very prominent cosmologist, by the way, says, from the point of view of general relativity, empty space is unambiguously something. According to general relativity, space is not a passive background, but instead a flexible medium that can bend, twist, and flex. The proposal that the universe was created from empty space seems no more fundamental than a proposal that the universe was spawned by a piece of rubber. It might be true, but one would still want to ask where the piece of rubber came from. Now, not to be deterred, there are a few cosmologists who say they can explain even this problem. As Lawrence Krauss, who's a cosmologist and also a very strident atheist, says in his book, the book is of course A Universe from Nothing, a quantum theory of gravity allows for the creation of space itself where none existed before. So they admit, yes, saying that there was a quantum fluctuation in space and then there's a Big Bang isn't really a universe from nothing, and it doesn't really tell you where the space came from that fluctuated. But Dr. Krauss is saying, wait, a quantum theory of gravity does explain where space itself came from. There's a problem, though, that he somehow forgets to mention in his entire book, and that's physicists don't actually have a quantum theory of gravity. Quantum theory of gravity does not exist. It's a famous problem in physics, been worked on for a long time. No solutions. Even Dr. Krauss admitted this in an interview. As he said, I also don't have a quantum theory of gravity, so I can't tell you for certain how space comes into existence. So in his best-selling book, he says, quantum gravity explains it all. We got it all figured out. In an interview later, well, we don't really have quantum gravity theory. I don't think that's being honest. Other problems with the Big Bang? Well, basic physics. If you take a physics class, one of the first things you'll be taught is a principle called the conservation of matter and energy. The idea that the total combined amount of matter and energy in the universe is always the same. Now, you may have heard the equation E equals mc squared, which is E, energy, equals m for mass, times speed of light squared, which is a large number. That tells us matter and energy have a relationship. They're equivalent in a sense. You can convert one to the other, but you can't create or destroy either one. So the equation tells us that a lot of energy, because this is a large number over here, it means a little bit of mass is equivalent to a whole lot of energy. And we can convert them back and forth, like I said. The most efficient way we know to convert matter into energy is via a nuclear explosion. A little bit of stuff converts into a whole bunch of energy, right? We can go the other direction. We can turn a lot of energy into a little bit of stuff. We do that in particle accelerators. You get little chunks of matter whizzing around at close to the speed of light, smash them together. More material comes out of the collisions than went in. So what's going on? Well, the kinetic energy, the energy of motion of those particles, is being converted into matter. But my point is, we're not creating matter here. We're just converting energy into matter. Just like the nuclear explosion isn't creating energy, it's converting matter into energy. So the basic idea is you can never create energy or matter from nothing. All you can do is convert the other thing into it. And we see this principle every day in our lives. Why do you need to eat food? Regardless of how difficult that process may sometimes be, right? Because your body needs energy, but can't get it from nothing, can't make it from nothing, so you have to get it from the chemical energy stored in the food. And we'll miss the mouth again. Why do you get a bill from the electric company every month? Because your appliances need energy to run. It can't get it from nothing, so it has to get it from the power company, which also can't make it from nothing. It gets it from coal or radioactive material or something else. And a lot of that stuff doesn't get it from nothing either. For example, coal is just plant matter, which came from sunlight, and so on. In fact, you couldn't be watching this presentation tonight if this principle in physics weren't true, because some of the principles of electronic circuit design are based on this principle, and of course that's electronics that we're using here. And if you take a physics class and ever solve a homework problem based on a violation of this principle, you're automatically wrong. Whatever number you're going to come up with is going to be wrong because that's how built into physics this idea is. But the Big Bang violates this idea on the largest possible scale. It says everything in the entire universe, all the matter and all the energy, sprang into existence out of nothing. Now, if you tell that to a secular cosmologist, he'll smile patronizingly and say, you know, you creationists just don't understand the beauty of the Big Bang model. You know, it seems like a violation of physics that nothing would have made everything, that everything came out of nothing. But that's not really a problem because everything is really nothing. On a net basis, the universe is nothing, and therefore the Big Bang didn't create anything. What do they mean by that? Well, cosmologists modeled the universe in such a way, when you add up all the matter and energy in the universe, you get a certain big number, we'll call it X. They modeled the universe in such a way mathematically that its gravitational potential energy, which would be a negative number, also adds up to X. So if you have a positive X and a minus X and add them together, what do you get? You get 0. So cosmologists modeled the universe in such a way that the universe is literally nothing. Now, there's a philosophical issue here, which is probably obvious. There's also problems with that calculation. Those X's that they're coming up with, you get to explain it to do their Lucy because those X's aren't actually what the universe would produce if you do that calculation. But let's give them that. Won't even talk about those problems. Let's say you can make that calculation. Is that still a valid explanation for the universe creating itself? Well, as Stephen Hawking said, the laws of physics demand the existence of something called negative energy. To get your head around this weird but crucial concept, let me draw a simple analogy. Imagine a man wants to build a hill on a flat piece of land. The hill will represent the universe. To make this hill, he digs a hole in the ground and uses that soil to build his hill. But of course, he's not just making a hill, he's also making a hole. In effect, a negative version of the hill. The stuff that was in the hole has now become the hill, and so it all perfectly balances out. This is the principle behind what happened right at the beginning of the universe. When the Big Bang produced a vast amount of positive energy, it simultaneously produced the same amount of negative energy. In this way, the positive and negative add up to 0. Always, it's another law of nature. So what does that mean? It means that if the universe adds up to nothing, then you don't need a God to create it. You see his motive here, right? This isn't just a scientific question for him. The universe is the ultimate free lunch. Who sees the problem in this analogy? Did the hole dig itself? No, you needed an external agent digging the hole. He had to expend energy to do so, right? Not to mention there's a context, an environment, the flat piece of ground to begin with. I was giving this talk down at Master's College one time. One of the students said, someone had to make the lunch. Now, I know that it was kind of abstract. Here's a more concrete explanation that I like to use. Early in my engineering career, I worked on a circuit that had a design very commonly found in loudspeakers and amplifiers, where one part of the circuit powers the rest of the circuit with 2 voltages, a plus voltage and a minus voltage, positive and negative. And the one I worked on, as it happened, was plus 40 volts on one and minus 40 volts on the other. And if minus voltage sounds weird, don't worry, you can do that. So here's a circuit that made plus 40 volts over here and minus 40 volts over here. You could argue that on a net basis, my circuit made 0 volts, according to this logic, right? Yet somehow, when I pulled the plug out of the wall, this thing stopped working, and the voltages all went to 0. The universe does not spontaneously split into offsetting positive and negative energies unless there's some kind of an external agent to make it do that, in this case, an intelligently designed circuit, and an external source of energy to make it do that. The atheistic cosmologist does not have either of those things in his Big Bang universe, does he? Because he denies that there's a creator. So the hole in the hill and all the rest of it, it sounds cute as an analogy, and it may even sound convincing as an analogy until you really think about it. Big Bang has other problems as well. Early on in the model's history, it was understood that the Big Bang model predicts the universe should be filled with magnetic monopoles, little particles that have a magnetic charge with only one pole. north or south, but not both. The universe should be full of these things if the Big Bang is true, but we haven't found a one. There's a horizon problem, which has to do with the distribution of temperature in the cosmic microwave background. That also disproves the Big Bang all by itself. And then there's something called the flatness problem, which is that the Big Bang should have produced a universe with geometric curvature, massively positively curved or massive negatively curved, but as close as we can measure, it's neither of those. The universe is geometrically flat. And if flat and curved universes sounds weird, it's just a measurement of the cosmos that we can do. Point is, the Big Bang should have made it one way or the other, very far one way or the other, but it's very precisely flat, which again is sufficient all by itself to disprove the model. However, cosmologists would tell you they have an explanation for all three of those problems called inflation. Inflation is the idea that early in the universe's history, the Big Bang happened and then suddenly inflated, ballooned outwards in size, exploded outwards in size really, by multiple times the speed of light. And for various reasons, that supposedly explains away those three problems. The problem is inflation is a process that's outside of physics. The particle that supposedly drove this whole process is called the inflaton. As this author commented, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universes, but all the solutions are mathematical conveniences with no particular physical basis. In other words, they write an equation about some magical process that needs to have happened in order to rescue the Big Bang model from the facts, but there's no physical reason to believe that math has any basis in reality. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. Other problems are also found in our latest, most precise measurements of the background radiation. Some authors are now complaining that this reveals that the required inflaton potentials are exponentially unlikely according to these measurements that we are now doing. And I'm skipping ahead a little bit. My point is, latest data are showing that not only is this process outside of physics, it's exponentially unlikely to have happened, even if it had somehow occurred. So if you're going to evoke a process with a particle that no one's ever seen, with a particle for which there's no room in the standard model in physics, by the way, making the universe expand by multiple times the speed of light for no apparent reason, and the process would be exponentially likely even according to the logic of the model itself, well, that's not a scientific explanation anymore. That's called a miracle. But without this, if this hadn't occurred, then these three fatal problems for the Big Bang model can come back. That means we know inflation is true because we know the Big Bang model is true. You see how all that works? Other problems with this idea are fine-tuning. Now, entire books have been written on how finely tuned the Earth is for us to live here, and I can recommend some of those to you if you're curious. You could also argue that the sun is finely tuned for us to be here. This is something a lot of people don't talk about. A 30-year study of the sun's photosphere was done not that long ago, and the sun varied in its energy output by less than 0.1% during that time. It's constant in temperature. Now, we don't think about that much, right? We take it for granted. I mean, the sun comes up and it goes down, and at least it does here on this side of the mountains. I'm from Seattle, so we don't we don't get to see it that much. But we don't think about it, right? Well, it turns out that stars don't behave this nicely. Most stars are very unstable and flare frequently, and that's a whole separate conversation. Even stars like the sun, though, of which there aren't that many to begin with, all the ones we've seen normally produce a bright super flare once a century. What's a super flare? Well, you know those eruptions on the sun's surface that you might see in the news or whatever, where some solar material blasts off into space, and they're worried about if it hits the Earth, it'll knock out a satellite or something? Multiply one of those by 1 to 10 million times. That's a super flare. And sun-like stars produce these things once every 100 years or so, which is scarily often if you think about it. Yet, as this quote points out, a super flare has never occurred on the sun in recorded history. And this author says why that's true is unclear. Well, it's not unclear at all. Go read your Bible. Isaiah 45 says, the Lord that created the heavens, formed it and made it. Why did he do that? He created it not in vain. He formed it to be inhabited. If an omniscient, omnipotent, benevolent God made the solar system for us to live in, then we shouldn't be surprised that it's a very nice place for us to live. In fact, fine-tuning arguments go far beyond the big things in the cosmos and actually even go to the little as well. As Sir Fred Hoyle, who is not a friend of creation in any sense of the word, argued that a supercalculating intellect must have designed the properties of the carbon atom. The carbon atom has such amazing properties for life to be possible that he says the chance of my finding such an atom through the blind forces of nature are utterly minuscule. A common sense interpretation suggests that a super intellect has monkeyed with physics. The numbers one calculates seem to be so overwhelming as to put this conclusion beyond question. Here's another author. You might be surprised by who said this one. A change of as little as 0.5% in the strength of the strong nuclear force, down at the atomic level, or just 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. You get this? It's not just the stuff we see. Physics itself appears finely tuned. Because if these constants were altered by only modest amounts, the universe would be very different and in many cases unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms, which would be a very bad thing, by the way. Our universe and its laws appear to have a design that's tailor-made to support us, and if we were to exist, leaves little room for alteration. That is not easily explained. It raises the natural question of why it is that way. Who said this? Stephen Hawking, militant atheist. A few years back, some people calculated the odds, or I should say, some people calculated how finely tuned the Big Bang needed to be to make the universe we see. The answer they got was 1 out of 10 to the 60th power. That's a 1 with 60 zeros after it. Someone made a joke and said it's like balancing a sharpened pencil on its tip for 14 billion years. But here's a more concrete way of looking at it. There's about 10 to the 80th power atoms in the universe. If the Big Bang made everything we see and had to be tuned to 1 in 10 to the 60th power, that means the Big Bang had a precision of only 10 to the 20th power atoms. That's about the same amount of matter in a single grain of sand. The calculation showed that if the Big Bang, the alleged Big Bang, had made 1 extra grain of sand somewhere in the entire universe, there would have been runaway gravitational collapse early in the universe's history, and we wouldn't be here to be talking about it. Conversely, if the Big Bang had made 1 grain of sand less than what the entire universe contains, there would have been runaway expansion, galaxies couldn't have formed, we wouldn't be here talking about it. Now, do you want to believe that a random event without a creator involved somehow made this universe to within a single grain of sand? But then the problem got worse. Other calculations show it's not just 10 to the 60th, it's 10 to the 123rd power fine-tuning. As this secular cosmologist said, some of the fine-tuning is extreme enough to be quite embarrassing. We have to tune dark energy to 123 decimal places. That's 1 out of this number, by the way. So now, if the universe has 10 to the 80th power atoms and the Big Bang that supposedly made them is finely tuned within 10 to the 123rd power, now your precision is a lot less than a grain of sand. It's a lot less than an atom within a grain of sand. It's this fraction of an atom is how precise the universe had to be. This is the number. As this secular physicist said, this realization is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe was made for man to be here somehow. You can tell what he thinks of the idea, right? Nevertheless, there are some cosmologists who say they have an answer for this. They say, yes, this universe is extremely unlikely, but that's not a problem because this isn't the only universe that exists. In fact, there's an infinite number of universes in reality. And so with an infinite number of universes, even the most unlikely ones are going to be there somewhere, and we just happen to live in one of those unlikely ones. Now, you may be scratching your head saying, how can there be more than one universe? Well, they've redefined the word. A universe now, sometimes, means that which we could ever see, even with the best technology. And the collection of all these infinite number of universes is called the multiverse, for multiple universes. And in fact, the Big Bang has now been recognized to actually produce a multiverse through the process of inflation. It's not merely that one universe forms, but once inflation starts, it never stops. It keeps producing universes throughout eternity until you have this infinite bubble universes, all through reality. Now let's think about the implications of this. If there are an infinite number of universes, there's only a finite number of ways you can arrange matter within, for example, something the size of a solar system. That means every possible arrangement of matter is going to exist an infinite number of times all across the multiverse. As this article says, is there another copy of you reading this article or listening to this presentation? A person living on a planet called Earth with misty mountains, fertile fields, and sprawling cities in a solar system just like ours. The life of this person has been identical to yours in every respect. Until now, when you're deciding to do something differently than some of your alter egos, you probably find this idea strange and implausible, that there's an infinite number of rooms just like this one where you are sitting in that exact same chair listening to the same presentation. But it looks like we'll just have to live with this idea because the simplest and most popular cosmological model today actually says that this is true. This doesn't even assume speculative modern physics. Oh, this isn't speculative. Ooh. If space is infinite and distribution of matter sufficiently uniform, then even the most unlikely events must take place somewhere. So there are infinitely many other inhabited planets, including not just one, but infinitely many, with people with the same appearance, name, and memories as you. So there's an infinite number of universes where we're having this same talk. There's an infinite number of universes exactly the same as this one. We're all sitting in the same talk, except you had something different for breakfast this morning. There's an infinite number of universes where the South won the Civil War. There's an infinite number where there never was a Civil War because the 13 colonies lost the revolution against King George III. You know, pick any story you want. It's out there an infinite number of times according to the multiverse, because even the most unlikely events must take place somewhere. And as silly as this idea sounds, this is very popular in cosmology today. As this physicist said, the multiverse is not some kind of optional thing, like can you supersize or not? He says it's there, and we need to deal with it. So as silly as this idea sounds, you better just deal with it, because that's what science proves to be true. Really? Well, let's think about some of the implications of this. There's other problems with this whole model that we could discuss. I'll limit myself to just a couple more. Number one, this whole thing ultimately is self-contradictory. If there's this infinite number of universes out there that are unobservable, that means they're outside of the universe we can observe, outside of the natural world. What word did we use to describe something that's outside the natural world? Supernatural. Isn't that what they criticize us for believing? And even some secular thinkers are unhappy with the situation. As this guy said, these multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. By definition, you can never see the other universes, ever. Hence, these theories don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. This author said, my own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks. Oh, we wouldn't know anything about that, would we? And becomes part of the conventional wisdom about how the world works. And if you think about this too, this whole idea proves the ultimate absurdity of the secular approach anyway. Jesus said in the book of Matthew, by their fruits you shall know them. So if the Big Bang were a good model, good scientific model, it would have good fruits. But if it's a bad model, it's going to have bad fruits. We come to a section that I like to call science or science fiction, where we look at some of the ideas being thrown around nowadays and trying to see what kind of fruit we're producing here. This author says, maybe we should approach cosmic fine-tuning not as a problem, but as a clue. Maybe it's evidence that we somehow endow the universe with certain features by the mere act of observation. Stephen Hawking is endorsing this. And long story short, observers are creating the universe in its entire history right now. The universe exists because you look at it. You create it by looking at it. And so if we create the universe, it's not surprising that it's well suited to us. Of course you would create a fine-tuned universe, right? That's the only thing you would want to do. Well, that's an amazing story, but is it science or just science fiction? Other people are trying to get rid of the beginning, where they say there's a multiverse, there's infinite baby universes out there. They're all springing into existence, making new babies of their own, but each of these would experience an arrow of time, but half of the baby universes would have an arrow that's reversed with respect to the others. So there's this infinite multiverse, infinite baby universes all making new babies, but in half of them, time flows backwards. Is that science? Science fiction. Others are trying to say that there wasn't a beginning because there's this infinite brain universe where each universe is kind of like a membrane that collides with other membranes, and that's the Big Bang, et cetera, et cetera. Science fiction. Then there's other implications. This author pointed out one of the implications of a multiverse. He wasn't talking about the multiverse specifically, but it holds true here. He pointed out that, if we're going to travel to other places, well, dinosaurs on Earth got killed by a freak asteroid collision. What if other places, they weren't? He said such life forms on other planets might well be advanced versions of dinosaurs if mammals didn't have the good fortune to have them wiped out by an asteroid collision. We would be better off not meeting them. Well, that's true, because there's nothing worse than meeting up with a dinosaur that has better weapons than you do, right? But think about this. If the multiverse is true, there's an infinite number of planets out there where humans are fighting advanced dinosaurs right at this moment. This is a documentary, if the multiverse is true. Isn't it? Multiverse proves everything to be true, somewhere. Other authors are trying to explain fine-tuning in different ways. As this one said, it's proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge, but also the technology to build universes. Because with an infinite number of universes, there's an infinite number out there with aliens who have gotten so advanced, they have such super-duper technology, they can make more universes. Maybe that's how our universe formed. This explains why the constants of physics have their observed finely tuned values. It might even help us understand why our universe is comprehensible to the human mind. So that's why the universe looks so well designed and fine-tuned, because aliens did it. Is this science or science fiction? Other authors are taking this idea further. Well, if aliens can have advanced technology, they can have computers that can simulate universes in them. It is a perfectly acceptable supposition that the world as we know it is a vast computer program, run on machines built by an intelligence we know nothing about, in a universe that could be like any of the ones we speculate about. If you accept the multiverse idea, it's almost inevitable that there are computer-based universes out there. Somewhere among the universes there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of a universe. So if you think we can do real science and go look at a real universe and go study things, well, you're wrong, because this isn't a real universe. We're just part of a video game that some aliens are running somewhere. Now, you might think that this sounds rather silly, but no, this is serious stuff. This is just one scientific paper that's been written on this. This study is trying to figure out constraints on the universe as a numerical simulation. By the way, this was funded by the US Department of Energy and 2 other agencies that receive government funding. These are your tax dollars at work to figure out if we live in a computer simulation. But let's take it further. If aliens can make computer simulations of universes, and in a multiverse they could, of course, then aliens can also simulate universes that contain aliens that are simulating universes, right? As this author's pointed out, and he's serious, by the way, there could even be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. So it's not merely that we're running on an alien computer, but that alien environment is itself part of a simulation being run by other aliens. And then why stop there? Maybe the simulation's all the way down. The computer that alien's running on is actually part of a simulation being run by an alien who's being run by an alien who's being run by an alien, and on it goes, right? Now, I'm not saying all cosmologists endorse this or even discuss it, but this is the logical outcome of multiverse theory, right? This is where you wind up, in complete absurdity. So why then do intelligent men and women, scientists, cosmologists, astronomers, buy into this stuff? Why do they endorse a theory that ultimately will lead there? Because, as this author says, if there's only one universe, you might have to have a fine-tuner. If you don't want God, you'd better have a multiverse, regardless of all the baggage that comes with it. The Bible says that the fool says in his heart that there is no God. Atheist scientists are therefore fools. Now, don't misunderstand me. I'm not saying they're stupid. These are very intelligent men and women. But if the Bible is the foundation of knowledge, if the fear of the Lord is the beginning of wisdom, then when you deny the Bible at the beginning of your model and try to figure out how it all got here without God, if you deny wisdom, wherever it is you wind up is going to be folly. And that's exactly where the atheists are today. Last thing I'll discuss is that this whole idea is self-refuting anyway. It disproves itself. How do I say that? Let's set aside all the problems I've talked about tonight. Let's assume something could come out of nothing and all the rest of it. Even if something could come out of nothing, though, you don't get our universe from a quantum fluctuation. You get something called Boltzmann brains instead. What does that mean? Well, as the New York Times explained, this could be the weirdest and most embarrassing prediction in the history of cosmology, if not science. If true, it would mean that you yourself are more likely to be a momentary fluctuation in a field of matter and energy out in space than a person with a real past in an orderly star-spangled cosmos. Your memories and the world you think you see around yourself are illusions. This bizarre picture is the outcome of a recent series of calculations, et cetera, et cetera. The basic problem is that it's hard for nature to make a whole universe. It's much easier to make fragments of one, like planets, you in a spacesuit, or maybe, in the most absurd and troubling example, a naked brain floating in space. Nature tends to do what's easiest from the standpoint of energy and probability, and so these fragments, especially the brains, would appear far more frequently in the models than real full-fledged universes. Alan Guth, probably the most prominent cosmologist in the country, who agrees this overabundance is absurd, pointed out that, quote, some calculations result in an infinite number of free-floating brains for every normal brain, making it infinitely unlikely for us to be normal brains. Here's what this is all about. The Big Bang, even if you could make something from nothing, the Big Bang is so mathematically improbable that it's far more mathematically probable for a single brain to pop into existence from a quantum fluctuation than the Big Bang universe. That means you are not sitting in this room listening to this presentation because this room isn't real. You popped into existence a few seconds ago. You're just a brain floating in the void, and you think, no, that can't be. I remember my whole life walking in this, whatever. Well, no, those are illusions. They're false memories. Because your brain had to pop into existence with the molecules arranged somehow, right? And they just happen to be arranged with all those fake memories. And the sensory input you think you're getting, that's an illusion too. Not that this matters anyway, because you're about to dissolve back into the thermodynamic soup you came from in a few seconds. But, well, better deal with it. That's what the models say. And if you think I'm making this up, well, here's just a few scientific papers talking about this. A typical observer in the multiverse is a Boltzmann brain. Oh, I should have mentioned, this idea is called Boltzmann brains, named after Ludwig Boltzmann, a physicist. In the eternally inflating vacua, observers are infinitely more likely to be Boltzmann brains than honest folk like ourselves. The most likely fluctuation consistent with everything you know is simply your brain fluctuating briefly out of chaos and then immediately equilibrating back into chaos again. This is called the Boltzmann's brain paradox. Avoiding Boltzmann brain domination in dark energy models. A note on Boltzmann brains. Boltzmann brains and the cosmological constant problem. I like this one. Can the Higgs boson save us from the menace of Boltzmann brains? Cosmologists are justifiably unhappy that this is what their model says. I mean, you know, would you like this to be the logical implication of your worldview? But even though once or twice they've thought they've solved this problem, it turns out Boltzmann brains are back. And indeed, this is what their model says. Now, who heard about this in the science programs? You got to dig deep in the cosmological literature to find this stuff, like all those papers I just showed you. This is not something they like to discuss openly, and for obvious reasons. So the mathematics of secular cosmology without a creator says you're not a real person with a real brain and a real body. You're not even a brain floating in the universe because there is no universe. It's just you. Now, if that's true, remember, it's infinitely more likely for that to be true than for the Big Bang to be true. Alan Guth himself, infinitely more likely. Well, that means that you're just floating in the void. There's no universe. And if there's no universe, then there was no beginning to the universe. And if there's no beginning to the universe, that means there's no Big Bang. The Big Bang model disproves itself. If the model is true, then it never happened, which means it never happened. So when atheists try to use astronomy, cosmology, science in general against the Bible, Christianity, they think they have this great weapon to use against us, but really the only weapon they have is this one. Because as the Bible says, professing themselves to be wise, they became fools. Again, I'm not calling them stupid. They're very intelligent. But they deny wisdom at the very get-go, they're going to wind up in folly. When you deny the truth, whatever it is you wind up believing is going to be a lie, right? So back to our secular timeline, we see the earlier parts don't work so well either. A lot of times in the creation evolution discussion, we're told this is religion versus science. They have the science, we have the religion. I think I made the point this evening that's not true. Science is on our side. Nor, for that matter, do we need to compromise with the Big Bang model. A lot of people think we need to accept the Big Bang model because it has a beginning, which they think is consistent with Genesis. We don't need that for reasons I can share with you later, because I'm running out of time tonight. The Bible says that in the beginning, God created the heavens and the earth. This is consistent with science. The idea of this not happening is not, because indeed the heavens do declare the glory of God in many more ways than we can understand. So if you like this perspective on astronomy, I have a free email newsletter. It comes out a few times a year. You're not going to get a whole ton of spam. Every time something interesting happens in astronomy, and they'll tell you half of the story or part of the story, the newsletter is to share the rest of the story with you. And as you can tell, the rest of the story is often quite fun. On the back table here, I have 3 DVDs available. This presentation had highlights from all 3 DVDs. So in the beginning, when I started talking about planets, that was taken from the full presentation. The full presentation goes through each planet one by one, including a lot of things I didn't have time to talk about tonight, even on the ones I did discuss. All the planets and quite a few of their moons as well. Each one discredits the secular origins model in a different way. I think it's a lot of fun. Very visual too. There's like 240 photographs and animations in there, in that one. The second DVD is Stars and Galaxies, talking about star formation, galaxy formation, the size of the cosmos, design in the cosmos, and what that tells us about our Creator. And then the third one is about the Big Bang model. Again, much more material than I had time to share tonight, just on the cosmology part of it. This is my website where the newsletter is available, and my time has come to a close. It's been my privilege to speak to you tonight, and I thank you for your attention. Thanks.